our hypothesis testing, we always had to start out with a null and alternative hypothesis. And within that hypothesis, you had whatever your parameter was, if we were talking about a mean or a standard deviation or a proportion, whatever. So when we looked at example 1 here, it said 46% of Americans did not trust the media, and we went to test if there's evidence to support the claim that they do not trust the media has increased. So our null was that the proportion was equal to 0.46, and the alternative was that it has increased, so greater than 0.46. To do this on your calculator, you are going to go into Stat, Tests, and we are actually going to look at number 5, a 1 proportion z-test. When we did it by hand, we calculated a z-score, so we're doing the z-test. Okay, so then it asks for the p sub 0, the null hypothesis proportion. So that is my 0.46. My x, we look back here and it said in their poll of 1,010, 525 did not trust the media. Remember when we did this example, we had to calculate our p hat, our x over n. So the x is the 525. The n, the total number of people in our study, was 1,010. And then we have 3 different options for the alternative. Not equal to, less than, or greater than. So we are testing greater than. And you can either have it draw a graph or calculate, which we just want to calculate. So it gives us a lot of information. Let's compare that to what we had on example 1. The z value, 3.81. Is that pretty close to what we had on ours? We had, what, 3.83? Why is it slightly different? Rounding. The p, that's the probability. Why does it have this e negative 5? That's scientific notation. You would move the decimal back 5 spaces. Remember when we actually went to look this one up, our table didn't go far enough and we just had to give the best option on the table. So our probability is 0.000069. The p hat is what we had in our table and so forth. So when we do them on our calculator, we need to know the x, the n. You still have to write your null and alternative. Then when you get to the end, I would expect you at the very least to write down your probability. And then you have to tell me, does that mean we would accept or reject? So my alpha is 0.05. If our probability is bigger than alpha, remember, then we fail to reject. If our probability is smaller than alpha, we reject. So since p is less than alpha, reject the null hypothesis. So same things that we did by hand, same conclusion. It just, we have the option of using the calculator to find it for us. Are there questions on that one?
What was the alpha?
The alpha is given in the problem was 0.05. That is like our level of significance. So basically any probability smaller than that, we reject. Other questions? So let's look at example 2. We've done it by hand. We did that last week. Let's do it on the calculator now. So we have to have some basic stuff. We have to check our criteria, which we did, and we did it by hand. This time, the null was that the proportion was equal to 0.46. The alternative, we just want to check if it's different. So the alternative was the not equal. If we're going to do it on the calculator, we need the x and the n. What's our x value? And the n? Okay. So stat, test, number 5. Our p is 0.46, x 559, n 1267. We are testing not equal to this time. Calculate. And so we get that our probability is 0.1794. Is that what we got by hand? Not exactly, but pretty close, isn't it? We got what, 0.18 by hand? So 0.179 is not too far off. So we reject if this is smaller than alpha. Alpha was 0.1. So since the probability is bigger than alpha, that means we fail to reject. Okay, we do not have enough evidence to prove that the population feels differently. All right. Questions on that? I know it's been a long time since we did this. There is another option for hypothesis testing. We can build confidence intervals. Remember, we've made confidence intervals before. So if you're looking at a confidence interval, essentially if your null hypothesis is within the confidence interval, then we can't reject it. So, you know, we're 95% confident it's between these two values. So if the null is in there, we can't reject. But if it's not, then we could reject. So we could use a confidence interval to decide. Let's try one of those. A 2009 study found that 34% of teenagers text while driving. A more recent survey found that 353 of 1,200 randomly selected teens had texted while driving. Does this suggest the number has changed? Use a 95% confidence interval to answer the question. So first, let's check the criteria. Okay. This is the percent, so we're dealing with the p. So remember, we're going to talk about p. We have to check that the n times p times 1 minus p is greater than 10. What's my n? The p. So that's 269, so it's definitely bigger than 10. We also need to verify if this be less than 5% of the total population. Would 1,200 teens be less than 5% of the total population? So that's good. So then null is that our proportion equals 0.34. The alternative, we have 3 options: less than, greater than, or not equal to. What would it be this time? Not equal to. And that's just because I want to know it hasn't changed. Okay. We have some different options for doing this. Look at your formula sheet. Do you guys remember when we talked about confidence intervals? It's the very bottom of your second page in chapter 9. We talked about confidence intervals about P. So it's P hat. How do I get my P hat? Mm-hmm. What's my X value? Over my N? So my P hat is 0.2942. So it's P hat plus or minus Z alpha over 2. We need that. Okay, we're talking about a 95% confidence interval. So that's saying 95% fall in the middle. So that leaves 5% for the end. So each end is okay. So the Z alpha notation, we have to find the Z value such so that 0.025 would be to the right. So we're looking for this Z value. Remember, the table gives us the amount to the left. So we need to look inside our table, the closest we can get to how much is going to be to the left. 0.975. So you're looking inside the table to find 0.975. So that is RZ. Does everybody see where I got that? It's been a little bit since we used those. Okay. So it's P hat plus or minus the alpha over 2 times, we're using our formula sheet, just filling in the formulas, P hat minus P hat over N, and what was our N value? Remember, this is an interval, so you do the -1. You should get that right. Okay, so we have to look. If the null hypothesis is in this interval, we fail to reject. If it is not, then we reject. So we are 95% confident the proportion falls between these values. Is my null 0.34 in this interval? No. So we would say So we are 95% confident it should fall between those. Since our value isn't in there, we would reject. Do we remember how to do confidence intervals on the calculator? We go to stat. We want an interval. Remember, it was a 1 proportion Z interval. It's kind of the same wording when we're doing the whole hypothesis test. We do a 1 proportion Z test. We're doing the interval, 1 proportion Z interval. So my X was my 353. My N was the 1200. My confidence interval was 0.95 in the problem. And if we calculate, then it does build our interval for us. Okay, so here's the interval, which is the same thing we got. Since the null hypothesis is in there, we would reject. Any questions there? Last one. I always make you verify the criteria. And have we ever had one where the criteria didn't work? No, but we could. So it actually turns out if your criteria isn't verified, so if like n times p times 1 minus p is not bigger than 10, that means we can't treat it as a normal distribution, so we have to do it as a binomial. Remember binomial? That was back in chapter 6, so a long time ago. Remember we had a special binomial table. I don't have one on this copy back on the sheet. So that was at the end of your formula packet. We had binomial distribution, and it gave us the probabilities of all these different things. So if we can't verify the criteria, then we have to treat it back as a binomial like we did at before we even learned about the normal distribution. So in 2006, 10.5% of all live births in the United States were to mothers under 20 years of age. A sociologist claims that births to mothers under 20 years of age is decreasing. She conducts a simple random sample of 34 births and finds that 3 were to mothers under 20 years of age. Test the claim at the alpha equals 0.01 level of significance. All right, so my hypothesis, my null hypothesis, is what? The proportion is 0.105. What's the alternative? Okay, let's check our criteria. N, which was 34 times P, 0.105, 1 minus P. So that's 3.195. Not bigger than 10, so the criteria fails. So that means this is not big enough to be called a normal distribution. Okay, so instead, if we can't treat it as a normal distribution, we have to use the binomial. All right. What is our p hat? 3 over so in her sample, she had 0.0882, which is less than the null hypothesis. But we need to see, is it enough smaller that we would consider it significant? We need to test. Is the probability of this happening less than 1%? All right. So we are going to have to find the probability, since we're doing less than, we want to check probability of being 0, 1, 2, or 3. I'm stopping at 3 because she had 3 in her sample. Okay. What?
How do you do that on the calculator?
So, we have our binomial table. But if you look across the top, when we're using the binomial table, this only works for certain probabilities. Our null hypothesis probability, 0.105, is that one on this table? No. So we cannot do it from our table, so we have to do the calculator. Okay, so there's actually 2 different options on here. If we can do the binomial formula, the n choose x, p to the x, 1 minus p to the n minus x, like we did it before. Do you want me to show you a shortcut on your calculator? If you go into second and then vars, okay, this takes us into all these distributions. We are looking for, okay, there's 2 binomial ones, PDF and CDF. The CDF is a cumulative, so it will go ahead, instead of us having to find the 0, the 1, the 2, and the 3 separately, it will find all of them added together for us. So that is the shortcut. So we went second, vars, and we went letter B, the binomial CDF. Okay, my trials. How many women were in her sample? 34. Okay, what is our p-value from the null hypothesis?
0.105.
And x, how many in her sample? And so then it gives us probability. Same thing we would have gotten if we worked each of those individually and added them together. It just does it automatically for us. So we get 0.5149. Okay. That is that something that would lead me to reject or not reject? Mm-hmm. Yes.
How do you get that on the calculator?
Go second, vars, and down to letter B, the binomial CDF. The trials is your n, the probability is from the null hypothesis, and then our x is the 3 that she had in her trial. So since our probability is bigger than alpha, that means we fail to reject. We do not have enough evidence to conclude that the probability has decreased. questions? So this is really the end of 10.2. We had started this before break, and I think you had started the 10.2 homework. Hopefully I've given you some class time, so I know some of you were finishing 10.1. I don't, so number 6, you had to do it with both the classical approach and the p-value approach, so that one you should have done by hand. Number 8, let's make sure that one, do it by hand as well. But then after that, if you want to use your calculator on all of them, you can. Okay, so I think before break, I kind of encouraged you to do those couple by hand ones before we learned how to do the calculator. So now you can do either option, by hand or using your calculator.